Good morning, senior twos. Last time we introduced ourselves to indices and we are able to list down the rules governing indices. Now today we are going to work out more examples on indices, whereby now today we are going to first note. This is a very big note. When simplifying numbers, when simplifying indices, sorry, questions. When simplifying questions, which have indices, we express the bases as a product of prime factors. Prime factors, you make sure that the bases are prime numbers. The base should be a prime number. That is a very big note. If you don't want to find problems as far as indices are concerned, always when you find such a question dealing with indices, make sure that you express the base as a product of prime factors. That is the senior one work. In senior one, we dealt with expressing numbers as a product of prime factors. Now, this concept, we are going to apply it more as far as today's questions are concerned. Let us look at some questions. Question one. Questions, we have simplify. Number one, we have 32. Question one, it is simplify 32 to power 2 out of 5 times 2 to power -2. We said that this is because here we have the power and the other one has power. Now we are dealing with the indices. However, we have two bases. We have 32 and we have a 2, implying that 2 is a prime number, our base 2. But 32, is 32 a prime number? No, 32 is not a prime number. Therefore, we express 32 as a product of prime factors. You remember, we can go aside and we express 32 as a product of prime number, such that we prime factorize 32. Which prime number do we use? It is a 2. By 2. 32 divided by 2, what do you get? We come up with 16. You continue. 32 by 2, we have 16 divided by 2, you get 8. You get what? 8. Also by 2, we get what? We get 4. By 2, we get a 2. By 2, we get what? We get a 1. So we have prime factorized 32. When we look at the side of 2, how many 2's do we have? We have 1, 2, 3, 4, 5. Now it implies that 32 is equal to the prime number we have. It is only 2, but how many 2's do we have? 1, 2, 3, 4, 5. So it is going to become to power 5. The number of 2's you have, that is the power of 2. Now we have made 32, we have prime factorized it. So we come back to the question, 32. We have seen that 32, it is 2 to power 5. 2 to power what? 5. Now we are going to come to our question, where there is 32, we substitute in 2 to power 5, such that we get 2 to power 5, that is 32. But remember, 32 is its power is 2 out of 5. So we introduce a bracket such that we have here 2 out of 5. It is 2 to power 5. 2 to power 5 has replaced 32. Then to power 2 out of 5 times 2 to power -2. Now we apply rules. Remember, when we have the value inside the bracket and we have the power of the bracket, the power is multiplied by the power. We have to first simplify this one such that we get 2 to power 5. Then times, we multiply the powers 2 times 2 out of 5 times 2 to power -2. Now this 5 is going to cancel with a 5 such that we remain with the 2. We are going to have 2 to power 2 times 2 to power -2. But remember one of the rules. So here we have applied one of the rules. You check in the rules governing indices, which we listed down last time. So here 2 to power 2 times 2 to power -2. But remember, when multiplying numbers of the same bases, you add the powers. Now this one is going to give us 2 to power 2 plus -2. Plus -2. Why plus? Because we are multiplying numbers of the same what? Same bases. Such that we come up with the 2 to power 2 plus -2 is the same as 2 minus 2, which is a what? Which is a 0. But remember, any number to power 0 is what? Is 1. Any number to power 0 is 1. So this one will become a 1. So we have simplified this one, but applying the rules governing indices. Another idea we have applied that please never simplify indices when the bases are not prime number. The base must be a prime number. Therefore, you should always express the base as a product of primal factors. Remember the prime numbers, we have 2, we have 3, we have 5, we have 7, we have 11. Those are prime numbers. So you make sure that the bases are one of those numbers I have stated. That is question 1. Question 1, which has given us 1, but we have applied the rules governing the indices. Now we can also try out another one. Question 2, we are still simplifying. Simplify. 1 out of 16. 1 out of 16 to power negative a half. To power negative a half. Class. Here the power is a negative. But we know that most of us fear negative. But remember, we have the rule governing indices. If you want to make this power a positive, what do? We remember that when you write the reciprocal, this is an indices because we have the value inside and the power. So what do? We say that when we write the reciprocal, the sign of the power changes. What is the reciprocal of 1 out of 16? Reciprocal means what has been a numerator becomes a denominator, and the denominator becomes a numerator. Therefore, the first step here is to remove that negative by writing what? Instead of having 1 out of 16, we have 16 over 1. 16 over 1. Now, when you write the reciprocal, the power is negative a half. Now it turns to a a positive. It has turned to a positive. But remember, any number divided by 1 is that very number. Is that very number. This one is equal to 16. 16 over 1 is 16, but to power a half. Now look at our base. Our base is 16. We have to prime factorize such that the base 16 is not a prime number. Therefore, you express 16 as a product of prime factors, as a product of prime factors. Now, what are we going to get? You can go aside and you prime factorize 16. Now we are prime factorizing 16. We start by what? By 2. 16 divided by 2, we get 8. We get what? 8. 8 divided by 2, you get what? You get a 4. 4 divided by 2, we get what? We get a 2. 2 divided by 2, we get a 1. So you have to prime factorize until you get a 1. How many prime numbers do we have? We have only one prime number, which is 2. But how many 2's are there? When you count them, 1, 2, 3, 4. Now, what does it imply? It implies that 16 is equal to 2 to power the number of 2's you are seeing. The number of 2's we are seeing, 1, 2, 3, 4. It becomes the power of 2. Now, where there is 16, our base must be a prime number. Here is 2. So we are going to have 2 to power 4. But remember, outside there is to power a half. The power is multiplied with the power, because the bracket has the power, which is a half, and inside 2 has the power. So you just write 2 to power a 4, and we multiply by a half. Here you come up with by 2, 1 by 2. 2 times 1, you get 2. So it is 2 to power 2. And 2 to power 2 means 2 times 2, which is equal to what? Which is equal to a 4. And that one becomes our answer. We are applying the rule. Here we have applied one rule. That rule, when you have the value inside the bracket with the power, and the bracket outside there is the power, you simply multiply by the power. But remember, we have to make sure that our bases are prime numbers. Are prime what? Numbers. Let us have another question. We are looking at other questions where we apply the rules governing in the indices, the rules. Now, let us have this one. What if you are given a question like 8 out of 125 to power? This is question 3. Is question 3 to power -2 out of 3 times 5 out of 8 to power a half. It is not 8.5, but it is 8 to power. The power is written up. But here we have squared. Squared. Now, what do we do? What do we do with such a question? We are going to apply the rules governing indices. The rules governing what? Indices. Let us see what happens. Are we there? Now, what we are going to do is very simple. When you see such questions, don't fear. Let us first look at the negative. Here we have to power negative. Now, this is a fraction, but it has a power negative 2 out of 3. Don't get scared. First, remove that power. Change it to a positive. What do? We write the reciprocal. What is the reciprocal for 8 out of 125? It is 125 out of 8. Since we have written the reciprocal, the power here is negative. It changes to a positive. Times this one is a positive. Don't tamper with it. So you get 5 out of 8 to power a half. Then to power 2. Hey, we should not get scared, but we should move slowly. Now let us continue. Let us do what? Continue. This one we can see, is 125 a prime number? No. Is 8 a prime number? No. Is this 8 a prime number? But 5 is a prime number. Now here it is only one value which we are not going to tamper with. We are going to tamper with the 8. Then you go aside. 125 is not a prime number. So we prime factorize it. Using what? We 2 cannot go through. We have 3. We have a 5. By 5, what do you get? You get 25. By 5, what do you get? By 5, you get 5. By 5, you get what? You get a 1. You get what? A 1. It implies that 5 is equal to, sorry, it is 125 is equal to 5 to power 3. 5 to power what? 3. Using the same approach, you are going to find that 8 is equal to 2 to power 3. 8 is equal to 2 to power 3. During your free time, prime factorize. The prime factorize 8, you will come up with 2 to power 3. Then you substitute in where there is 125, we are going to put there 5 to power 3. Over where there is 8 here, we are going to put what? We are going to put 2 to power 3. Multiply by. Now there is a power here. There is a power 2 out of 3. Multiply by. Here there is a 5. We have not tampered with the 5. But here there is 8. 8 is replaced with the 2 to power 3. So over 2 to power 3. But remember here it is 8 to power half. You are going to press here a half. But remember to power a 2. When we are dealing with the indices, now we are applying the rule. We are applying the rules. This one is equal to, the power is multiplied by the power. 3 times 2 out of 3. The power with the power. 3 times 2 out of 3. You are going to find that we have 5 to power 2 over 2 to power 2 times, where are these values coming from? There is this power, you multiply it by this one, it will give you a 2. There is this power 3 of 2 times this one, it is also going to give you a 2, such that when we simplify this one, first we get 5 to power 2 over 2 to power 2. Then times, now we are going to this. 5 is the same as 5 to power 1. Any number to power 1 is that very number. So the power is multiplied with the power. Meaning that here we are going to get 5. Sorry, 1 times 2, because this is the power and this is the power. 2 times 1, you get 2. That one gives us 5 to power 2 over what? Over Here, this 2 times the power here, 2 times a half, you get 1. So we are going to remain with 2 to power 3, which is equal to. Now we are applying the rules governing indices. Remember, in fractions, when multiplying fractions, you multiply the numerator with the numerator, the denominator with the denominator. We remember, when multiplying numbers with the same bases, what do? You add the powers. 5 to power 2 times 5 to power 2. We are going to add the powers and we come up with what? We are going to come up with the 5 to power 2 plus 2, because we are multiplying numbers of the same bases. So we get 2 plus 2 over, here we are having 2. When multiplying numbers with the same bases, you add the what? The powers. 2 power 2 times 2 to power 3. That one you come up with 2 to power 2 plus 3, which is equal to 2 plus 2, you get 5 to power 4 over 2 to power, so you get 2 to power 5. This one can be simplified. 5 to power 4 means multiply 5 4 times 5 times 5. 25 times 5, 125 times 5, you get 625. So our numerator is going to become 625 over. Here multiply 2, how many times? You are going to multiply 2, 5 times 2 times 2, 4 times 2, 8 times 2, 16 times 2, you get 32. Now our answer becomes 625 over 32. We are passing through. They can bring some questions where you apply almost every rule governing indices. Follow through. Here, when we write the reciprocal, the sign of the power changes. Then, but remember, we have the concept. The base must be a prime what? A prime number. You make sure that you convert it to a prime what? A prime number. Are we together? Now let us get another question. We are still on the same question. Simplify. In most cases, we simplify indices without using a calculator. Don't pull out a calculator. Calculator is not important as far as simplifying indices are concerned. Next, they can ask you to simplify a question which has decimal places. Please don't fear. But if you are asked to simplify 0.00080 to power 1 out of 3, to power 1 out of 3. Dear students, you shouldn't fear this question. Just simplifying. Now, what we normally do for this case, just convert this 0.00. Before you simplify, convert it to a fraction. There you won't find any challenge. 0.008 to power a third. What do you get? We simply get here. The first step is to convert this bracket into a fraction. What do we divide by? We just get 8 divided by, which value are we dividing by? It is 1,000. Therefore, 8 is the same as 0.008 is the same as 8 out of 1000. But remember, the power of 0.08 is 1 out of what? 1 out of 3. Now we are simplifying. Is 8 a prime number? No. Is 1000 a prime number? No. Go aside. If you prime factorize, I think now we know how to prime factorize. 8 is going to give us 2 to power 3. 2 to power 3. And 1000 as a product of prime number, we want to make 1000 a prime number and 8 a prime number. We express 8 as a product of prime factors and 1000 as a product of prime factors. During your free time, go back to senior 1 and at least we know we use ladder what? Ladder methods. Use ladder methods such that you can show how you get 2 to power 3 from this. Then 1000 as a product of prime factor, we are going to get 2 to power 3 times 5 to power 3. Go aside and make sure you express 1000 as a product of prime factors. We continue. This one is going to give us, what are we going to get? We are going to get 8. Where there is 8, we are going to substitute in 2 to power 3. Over where there is 1000, we are going to substitute in 2 to power 3 times 3 to power times 5 times 5 to power 3. But remember, all of it to power 1 out of 3. Now we said that if we have such a bracket, there is a base 2, base 2, base 5. So these are prime numbers. Now we look what the powers. The power outside the bracket is going to be multiplied out by it. You multiply it by each of the power inside. This one is going to give us what? 3. The power. This is the power and this is the power. 3 times a third is 1. So you get 2 to power 1. This one has come from where? By getting this 3 and multiply it by a third. Over the same, this a third is multiplied by this 3 in the denominator. So you get what? You get 2 to power 1 times it is the same. 3 times a third, you get what? You get 3 to power, it is 5. 5 to power 1. Any number to power 1 is that very number. But can you see that we have 2 to power 1 and 2 to power 1? This one is going to die with this. Such that in the numerator you remain with, by the way, 2 to power 1 is 2. Out of 2 to power 1 is 2 times 5 to power 1 is 5. This 2 cancel with this one and we get 1 out of 5 as the final what? Final answer. You look, we are applying the rule. Now which rule? We have that rule for the brackets. So when you get a question about indices which has decimal places, first convert it to a fraction. After convert it to a fraction, express each number as a product of prime factors, as a product of prime factors. Good. That is it. These are some of the questions which can be asked, but always express the product, the base as a product of prime factors, as a product of prime factors, as a product of prime factors. Now, our next chapter which is very important, or part in indices. It is solving. Can we solve equations involving indices? Solving equations in indices. Here, note which is very important. The concept we use is if we have a to power m is equal to a to power n. If the bases are equal, the powers are also equal. This one implies that since here on the left hand side the base is a, and here the base is a, when the bases are equal, even the powers are what? Are equal. What does it imply? It implies that m is equal to n. M is equal to what? N. If a to power x plus 1 is equal to a to power 2x. Solve. Now you can see using this the other approach that when the bases are equal, the powers are also equal. What is the base on the left hand side is a. Even here the base is a. Now if the bases are equal, the powers are equal. What does it imply? It implies that x plus 1 is equal to 2. xy, the power here is x plus 2, and there the power is 2 what? 2x. Now you collect like what? Like a terms, and you solve for what? For x. So let us collect like terms. This one goes the other side. We are going to have 1 is equal to 2x minus x. 1 is equal to x. Now you have solved the equation involving indices. We can also try out now. We have noted that wherever you find an equation involving indices, what you apply is you make sure that sometimes the base on one side should be equal to the base on the other side. Questions solve for x. Solve for x. Number 1, we have 2 to power x minus 2 is equal to 2 to power 7. 2 to power 7. This is it has the base and the power. The base and the power. There is an equal sign. Now we are solving the equation. The bases are the same. The base on this side is 2 and the other side is 2. Now what does it imply? Since the bases are equal on both sides, even the powers should be equal. What is the power this way? Is x minus 2 is equal to 7. So you take a 2 on the other side, you get x is equal to 7 plus 2. X is equal to 9. So we have solved that question by applying the concept that when the bases are equal on both sides, even the powers are what? Are equal. But before you apply it, make sure that the bases are prime numbers. 2 is a prime number, 2 is a prime number. Are we together? Question 2. Question 2. Solve for x. We are solving for x. 9 to power x minus 7 is equal to 3 to power 2. Solve for x. Let us pay attention. We are solving for x. We have a 3 here on the right hand side. The base is a 3, but here the base is a 9, and we said that the base must be a prime what? A prime number. 9 is a prime number? No, a prime number is a number which has 2 factors, 1 and its so. So if 9 has more than 2 factors, therefore it is not a prime number. When we prime factorize 9 is equal to 3 to power 2. 9 is equal to 3 to power what? 3 to power 2. 3 to power 2. I think at this time you know how to express the number as a product. You use the random method. By what? By 3 by 3 you get 1. It implies that 9 is equal to 3 to power what? To power 2. So you should practice how to express numbers as a product of prime factor. Here the base is not a prime number. Now what are we going to do? What we are going to do is very, very simple. It is get where there is a 9. Where there is a what? A 9. You put in what? You put in 3 to power 2. But remember, outside the bracket there is x minus 7 is equal to 3 to power 2. Another concept we can use, the power multiplies with the power. But this 2 here is multiplied by x minus 7. It affects a 2, and so this one is the same as 3 to power 2 multiplied by x minus 7 is equal to 3 to power 2. Is equal to 3 to power what? To power 2. Now we open the brackets. 2 times 2. So we get 3 to power 2 x to power 2 x minus 2 times 7 you get 4. You get 14 is equal to 3 to power 2. Now the process through which you have gone, it has made this base equal to the other base. We have base 3, even the powers must be equal. This implies that since the bases are equal, the powers are also equal. So you remove the power, here it is 2x minus 14 is equal to 2. Now we solve this equation. We are going to get 2x is equal to 2 plus 14. 2 plus 14, what do you get? 2 plus 14, you get 2x is equal to 16. Now to get x, we simply divide by 2. And we come up with what? We come up with x is equal to 8. Are you seeing how you have solved the equation using the concept of indices, that the bases should be equal on both sides? But please, even if it is solving equations involving indices, make sure you apply the rules and express the number as a product of its prime what? Prime factor. Good. That is great. Now let us solve one other question. And we say that here this topic is very, very simple, provided you know the rules governing indices. Look here, question 3 for solving equation. Let us solve the equation. We are having 32 to power x. 32 to power x times 1 out of 8 times 1 out of 8 times 4 to power x plus 2 times 4 x plus 3. X plus 3 is equal to 2 to power 24. To power 20 what? To power 24 members. This is a number, but our role is to find the x, that is solving the equation. What do we do? Before you tamper with anything, look what the base is. Is 32 a prime number? No. Is 8 a prime number? No. Is 4 a prime number? No. Is 2 a prime number? Yes. Now what we need to express as the product of prime factors, it is 32, 8 and 4. Now at this moment, all of us we know how we express the number as the product of prime factors. Look what is 32. When you express 32 as the product of prime factor, I need you to work it out to express 32 as the product of prime what? Factor. How we find that 32 is equal to 2 to power 5. And if 8 is equal to 2 to power 3, then 4 is equal to 2 to power 2. Now what I need you is to come and substitute in. Where there is 32, put there 2 to power 5. Outside there is x times 1 out of 2 to power 3 times 2 to power 2. Here we have x plus 3 is equal to 2 to power 24, such that we get 2 to power 5 x times 1 out of 2 to power 3 times 2 to power 2 into x plus 3 is equal to 2 to power 24. Now for me, I'm going to stop from here. Now I want you to continue with this solution until you get the value of x, but make sure you apply the rules, more especially on this side. Make sure you apply the rules governing the indices and complete this question such that you get the value of x. Thank you for